To understand the true capability of a sports car, engineers look to the Nürburgring Nordschleife. This winding, punishing asphalt track in Germany is the industry benchmark for measuring automotive endurance. In 2014, BMW made a significant change to their lineup. They separated the coupe versions from their M3 sedan, giving the two-door model its very own nameplate, the M4. That new badge carried immense pressure. For decades, the M division had dominated global car racing, and the incoming coupe had to prove it belonged to that pedigree. If we look at a timeline of the M4's lap records, we start right here. The first-generation 2014 base model, powered by the twin-turbocharged S55 inline-6 engine, set an initial baseline of roughly 7 minutes and 50 seconds. A 7-minute and 50-second lap is fast for a street-legal car, but in the world of professional track racing, engineers viewed this as a starting line. To go faster, they had to fight the hard limits of physics and heat. 2 years later, the M division released a purpose-built track weapon aimed at breaking the 7.5-minute barrier, the 2016 M4 GTS. Looking back at our lap time chart, the engineering results were immediate. The GTS dropped the record down to 7 minutes and 28 seconds. Achieving that speed required a massive increase in turbo boost pressure, which generated extreme engine heat. Traditional air-to-liquid intercoolers could no longer manage that thermal load during a sustained track run. BMW engineers turned to a technology that had been absent from production cars since the 1940s. They installed a water injection system that sprayed a fine mist directly into the engine's intake manifold to flash cool the incoming air. By chilling the intake charge internally, the S55 engine could safely process enough air to push 493 horsepower without internal heat damage. The GTS pushed the original F82 chassis and the S55 engine to their absolute maximum limits. To shave any more time off the clock, engineers realized they would have to reinvent the entire powertrain. That revolution arrived with the second-generation G82 platform, featuring an entirely redesigned inline-6 engine known as the S58. The 2022 M4 CSL pushes this new architecture to its extreme limits, designed to deliver lap times that rival dedicated supercars. To handle 21.7 psi of turbo boost, the S58 engine utilizes a closed-deck aluminum block. This creates a much stronger frame around the cylinders compared to older open-deck designs. This diagram shows the inside of that engine block. To manage the heat, BMW used 3D printed sand cores during the casting process. This allowed for complex cooling channels that wrap tightly around the cylinders, dissipating heat better than traditional casting methods. Beyond the engine, the CSL, Coupe Sport Lightweight, underwent a significant weight reduction. By using carbon fiber components and removing the rear seats, engineers stripped 240 pounds from the chassis. This chart shows the culmination of that power and weight reduction. The G82 CSL settled at a record-setting 7 minutes and 20 seconds, a full 30-second drop from the first-generation baseline. Shaving half a minute off a Nürburgring lap time in just one generation is not the result of simple tuning. It requires a complete reinvention of the vehicle's thermal and structural limits. BMW uses the Nürburgring as a high-stress laboratory to validate its engineering before it ever reaches a consumer showroom. The exact chassis developments and S58 engine architecture pioneered in the road cars form the foundation of BMW's professional race vehicles, such as this M4 GT4. The hardware is robust enough that the top-tier M4 GT3 actually runs a detuned version of the S58 to comply with FIA racing regulations, proving the stock engine is engineered beyond the requirements of global racing standards. With that resilient architecture, the M4 has secured class victories in the IMSA WeatherTech Championship, the DTM Series, and the Nürburgring 24 Hours. The M4 is a championship-winning motorsport platform, ensuring that every consumer model directly inherits the DNA forged on the world's most difficult starting grids.